Alright, life's got problems, let's find solutions. This video is on rounding with sig figs, and specifically the multiplication and division rules, which are different rules than addition and subtraction rules. So if you haven't watched that video, you could go back and find that one too. But we're going to discuss what are the rules when I multiply or divide two or more numbers together. When do I round and how do I do that rounding with sig figs in mind? So we got two measured values here. I don't know, are they centimeters? Is this grams, miles, candelas? Who cares? The point is we've got 2.6 being multiplied by 114.5. Now let's just do this the old school math way. Plug that into our calculator. 2.6 multiplied by 114.5. Back in third grade, we would have told the teacher, hey, 297.7, and we would have gotten a sticker for the day, and everything was all set. Our world was great. But now you're dealing with sig figs, and we're going to call you out and be like, hey, man, you don't know that number that precisely. 297.7, that's really precise. If you did watch the previous video on rounding with addition-subtraction rules, you might say, hey, this looks fine to me because our two numbers have precision to the tenths place, so shouldn't our answer? And no, that's not the case with multiplication and division. Let me tell you why. Since you don't know anything about this area here, and that's not a zero, that's just my little mystery area. I don't know what is going on there, and I don't know what's going on here either. Whatever this uncertainty is, when I multiply these two numbers together, I have also multiplied the uncertainty. I have multiplied how little I know about that spot. That's going to carry over into larger values. If, let's say I didn't know a hundredths place and a hundredths place that was going on here, but I'm multiplying this unknown by 2.6, and I'm also multiplying this unknown by 114.5, these unknowns become bigger. They become large enough to where it's not just confined into the hundredths place. And so this is going to actually carry over into some of the other places, the tenths place and maybe even the ones place. There's a different rule for rounding with sig figs when you're doing multiplication and division. Here is the rule. The rule is you will round your answer to the number of sig figs. So your answer has the same number of sig figs as whichever data number, whichever measured value, had the least number of sig figs. So with multiplication and division, it's all about the least number of sig figs. Not about the degree of precision of the measurements, but which one has the least number of sig figs. In this case, it's 2.6. This only has 2 sig figs. Over here, this one has 4 sig figs. So my answer has to be rounded to 2 sig figs. That means I'm going to be looking at, well, I can't just write like, oh, well, 29, 29, because obviously 29 is not the answer, right? Our answer should be 297.7 and around there. So this is my first sig fig. I know the answer is definitely above 200. And then this is my second sig fig. This is a 9. Now, I know those very well, so I might want to say like 290, but wait a minute. This 7 here, this is a number that's 5 or above, so that's going to round this 9 up. Do you know how to write our answer then with 2 sig figs? We're really looking at, if we round this up, that 9 goes up, it's going to make this 300. Our value is going to be 300, but I can't just write this only has 1 sig fig. This was covered in a previous video. There's only one way to really do this. I can't put a decimal here because, oh, now I got 30 instead of 300. So no, that's not the way to go. What do we have to do? We've got to use scientific notation. I'm going to have to call this 3.0 times 10 to the second power. And now I am saying the value of 300, my times 10 to the negative 2, this is just the size. This is just the zeros that are showing you how big it is. But this 3.0, this is letting you know the precision. So there's my rounded answer, rounded with the correct number of sig figs. 2 sig figs, because in my data, the least number of sig figs was this 2.6. Let's try another one. Alright, here's an example problem. This one involves multiplication and division, but that's no problem. It's the same same rules for both, and so I'm going to do all of this math, and I'm not going to do any in-between rounding. This is where I think a lot of students will make a mistake. There's a misconception here. They think they need to round in between these steps. They'll do this math first and then round their partial answer. Then they'll do this math next and round their partial answer and use those rounded values to do a calculation. No, no, no. This is all multiplication and division, so we're going to go through this whole problem and do just multiplication and division. Also, did you pay attention in math class? Do you realize that you could look at this as 3.82 times 41.07 and then divided by 1.69 and then divided by 0.005201? I'm not sure if that matters to you or not, but just let's be a good refresher here is you can do these in any order. Order of operations for multiplication and division means I could say 3.82 divided by this lower denominator, then multiply that by 41.07, then divided by 1.69. If it's on the top in the numerator position, you can multiply those in any order, and if it's on the bottom in a denominator position, you divide your answers in any order. Does not matter. So we can just go ahead and calculate this out any old which way we want to. Let's see what our raw answer is going to be. 3.82, and multiply that together with 41.07. That's just how I like to do it. Multiply everything on the top together. I hit equals, and that's my raw number just of these two multiplied together. Now I'm going to divide that by what's on the bottom, divided by 1.69 equals, and then I'm going to divide it by this other one, divided by 0.005201 equals. Here is my raw value. 17,849 point some odd change. Now obviously I don't really know that number that precisely. I don't truly know that that's exactly what my answer is with all these measured values being multiplied and divided together. But here's my raw number. Okay, so again, the rule is for this raw value to be rounded, I have to round it to how many sig figs my data with the least number of sig figs has. So my first data point has 1, 2, 3 sig figs. My second, 1, 2, 3 sig figs. My third, this has 1, 2, 3, 4 sig figs. So I'm still limited to 3. Let's check this last one. Now here's again where some knowledge of your sig fig rules and how to tell how many is going to come into play. 0.00, those first 3 zeros are just placeholders telling you how small that number is. So they are not significant. But the 5, 2, 0, 1, those are significant. So I've got 4 sig figs here. Again, 3, 3, 4, and 4. So my answer must have 3 significant figures. So here's my first, here's my second, here's my third, and then the next number is not 5 or above. Look at that. I didn't plan that, but it's really close to being it, but it's just not close enough. So I'm going to have to call this, when rounded, 17,800. And there's my answer with 3 sig figs. Now, I want to also just mention, I understand that with this multiplication and division method, what about when you're dividing? If you're multiplying and your uncertainty increases, if you're dividing, doesn't your uncertainty decrease? Well, there's arguments for that. But this is one set of significant figure rules that sometimes scientists and engineers use. Now, I know also maybe if you're a scientist or engineer, you stumbled upon this video and you're watching that, you might say, hey, that's not the way we do it at the place I work. And that's true. There are other sets of rules out there. There's other ways that industry does it. Or maybe if you're a student and mom or dad is an engineer or a scientist, they might say, well, this is not what we have to do. But this is what I had to do in college. This is what the AP exam, the rules that they would expect you to use, and it's definitely what we're going to use in my class, so just be aware of how to do that. Quiz time, sucker! Alright, here's your problem. Oh, this, by the way, this is a boombox. It's what we used to play music on. You plug it in sometimes, or it had batteries in there. You didn't charge it. It has an antenna because it picks up radio stations. Quiz time! Okay, so everything in here is multiplication and division. 302.1 times this ratio here, which in the numerator position has its own ratio. And then in the denominator, it's got 0.280. And then all of this is actually the numerator for the total problem, which gets divided by 107.4. You can do really any of this in any order that you want to because of order of operations. It doesn't matter which order you were to type it in. But you got to just make sure, am I really dividing this by what it should be divided by? So I would say in a problem that is this complex, yeah, maybe you should do some separate simplification here. So let's go ahead and simplify this a little bit. But before I do, go ahead and try this on your own. Pause the video now. Press play to see how I work it out and get the answer. Go for it. You can do it. Okay, so again, since this is all multiplication division, no in between rounding. We're going to keep things raw. So let's start with this little interior part here. 16.2 divided by 140. 16.2 divided by 140. I'm going to keep these numbers raw. Now, do I really need to write down all of that? No, probably not. All right. When I go to do a problem like this, before I even get into this, we can decide already how many sig figs our answer should have. We can look at the data and decide which one has the least number of sig figs. So as you're looking through it, this one I hope you can see has 4, 16.2 has 3, 140 only has 2 sig figs. That 0 is just a placeholder, letting you know how big the number is. 0.280 actually has 3 sig figs. This 0 is a measured 0. This first one is just letting you know that the number starts in the tens place. This one here, though, is a measured out value. 107.4 has 4. So this 140 has the least number of sig figs. It's only got 2. So our answer is going to have 2 sig figs. It's good to know that just going right in. Now, also, I'm going to, even though I don't have to, this is kind of a complex problem, so to keep some things straight, I am going to do some in-between work here just to simplify it for myself. But when I do, no in-between rounding. You do not round in between because there's no reason to. These are all being multiplied and divided. We're all within the same category, the same rules. And so I'm going to do some simplification. When I do, I'm going to write down my side work. So let's start right here. This 16.2 divided by 140. Let's treat that like its own little separate problem here. And so I've got 16.2 divided by 140. And I get this number. And how much of that should I keep? Well, you can store that on your calculator. That might be nice to do. But I'm going to write it down. I'm going to write it down raw here mostly. I don't need to write every single one of those numbers. But I'm going to take it out just far enough to where I know I'm being pretty safe. Since I know I'm going to round my final answer to 2 sig figs, if I write down this many, I'm pretty safe here. So now I've got my new problem. I need to take that value and divide it by 0.28. Now it is still in my calculator here, so I'm just going to now divide this by 0.280. When I do, I get this new raw value. So I can actually now say that this has all been replaced by 0.41326 and some odd change. I don't need to write all of that, and it is still right here in my calculator. If I accidentally hit clear on my calculator, then I've got it written down as to what my partial answer so far is. So now it becomes 302.1 times this value. It's still in my calculator, so I'm going to multiply it by 302.1. And when I do, I get this new raw value, 124.847 and some odd change. So that's what all of this raw equals out to be. This all equals 124.847, yada yada. So now my last step, divide that by 107.4, divided by 107.4, and I get, here's my actual raw answer. My final raw answer from all of this overall, 1.16245 and some more stuff, but that's enough to definitely see what I have to round it to. I've got to round this to 2 sig figs, and so I'm going to look at my one, look at my next one, there's my 2 sig figs, but the next number over is 5 or greater, it's a 6, so this becomes a total of 1.2. Is that the answer that you got? If not, you can go back through that and just try it again, see if it makes sense, see if the logic makes sense. Now, a question that might be popping into your head right now is, okay, well, what about math problems where we have multiplication, division, but we also have addition and subtraction in there? What do we do for that? Well, that's what the next video is going to show you. So I like to call problems like that switching gears, and the next video is going to deal with the switching gears situation. Thanks for watching.